Okay, so what we're going to do today, we're going to talk about lots of things. We're going to talk about, review a little bit about definition of derivatives and also talk about new definition of derivative. It's called alternative derivative. And then we're going to show you how to work, and we're going to show you how differentiable, when it's not differentiable, when it's differentiable. So, we're going to start with definition of derivative. Definition of derivative, and definition of derivative has f prime of x is equal to limits as h approach 0 of fx plus h minus f of x over h. And so this will tell me, so this tells me, tell slope at any given x value. So it's a generalization. So if I take a derivative of x squared, I'm going to get 2x. And that 2x can find out slope at every single point of the things. Am I doing okay? Okay. Now, today we're going to learn something called definitions. No, alternative. So, alternative form of derivative. Now this one is like a weaker version of definition of derivative because you only can tell slope at one value. Okay, so the only difference is f prime of c. So instead of x, it's going to be c. C is some type of constant, and it's the limit x approach to c of f of x minus f of c over x minus c. Now, what happened is you're going to have that situations, and then you can say, okay, well, what does this mean? It's very similar like a previous case, except we only want to find out one particular c value, and so something like this point and this point, and so if I have some type of curve, maybe like some type of e to the x function or something like that, and then we're gonna call this point, we're gonna call it c, and we're gonna call this x. We just started. So we just talked about whatever yesterday. The definition of derivatives tell me the slope at any given x value. And today we're using alternative form of derivative. It tells you a single point, only one point that you want to evaluate. So at this case, we're going to call this coordinate c and f of c. And this point is going to be x comma f of x. Okay. So then basically idea is when x approach c is basically we approach this way. We shrink, we close in the x towards c. Okay, so we shrink the distance going this way. So this point is going to be this way, this point is going to be, eventually it's going to draw a tangent. So it will start with 2 points like this, and start with 1 point like this, and start with 1 point like this, and then start with 1 point like this, and eventually it gets so close it's going to be the tangent line. Does that make sense? you reduce the distance. So this distance is getting smaller. It's going toward this way. The more I get closer that way, it's more likely to become 1 point. Or 2 points that's very, very close to each other, so almost look like a 1 point. So that's that. So I can pick any function. I can say, hey, f of x equal to, I don't know, give me a number. 4 x squared minus what? Minus 3x? And what? What's the next number? Plus what? 1. 1? Okay. You pick an easy number. Alright, that's fine. I want to c is equal to, I want to find derivative of that c. C is equal to, give me another number. 2. Well, you guys pick easy number. Let's pick like fun number, 5. And we say, can we use the definition of derivative, find out the derivative at c equal to 5. We just have to apply the equation. Okay. So let's start with it. Limit has to, so start with f prime of 5. Because that's the left hand side, right? Limit has to approach what? X had to approach what? C. What's the C in this case? 5. Okay, good. And then I'm going to get f of x. What's the f of x here? 4x squared minus 3x plus 1. Good. And what is f5? I have no idea what f5 is. I'm going to evaluate it. 4 times 5 squared minus 3 times 5 plus 1 equal to 100 minus 15 plus 1. So you say 86. Ooh, that's an ugly number. Minus 86. Does that make sense? And it's going to be x minus 5.
So are you going to be able to choose any number or is this just for example?
This is an example. And the number is chosen by you guys. I didn't really pick. Well, actually, I picked 5. Because I thought 2 was too easy. I won't pick some number that's really hard to deal with. So then I will have limit as x approach to 5 of 4x squared minus 3x minus 85 over x minus 5. Ooh, factor of this one is going to be fun. So I kind of need a box here to help me. I'm going to do 4x squared minus 85 minus 3x. So I'm going to do 4x and 1x because I know the bottom is going to be x minus 5 in order for them to cancel. So I'm going to do that. This. And also think about, if it's a 5, then probably 5 is going to be here. 5 times what equal to 85? 17. So then you will have what, 20x, right? 17x. Well, that's good because I just need to make 20 negative, right? And it worked out perfectly. So limit x approach to 5. And it's going to be 4x plus 17 times by x minus 5 over x minus 5. So now cancel out. That's going to be limit x approach to 5 of 4 times 5 plus 17, which is 20 plus 17, which is 37. So the slope at 5 is equal to 37. Does that make sense? You just review how to factor. So I'll let you try one. So I don't know, pick, I don't know, 6x squared minus 2x minus, I don't know, 1. SC is equal to, I think C is equal to 3. And see if you guys can figure out. Yeah. You got an answer? Oh, because you take it to a power roll? Yep. No, I need to see the work. Well, I know how to do that too, but I need you to see if it work out and see if you know how to factor, right? It's not a key of asking, like, see if you know how to do something. I need all the things like understand, because there are some times that you cannot use power rule to take a derivative. I'm gonna give you an example that there's a case that you cannot use a power rule to take a derivative, and yeah, but think about you have to make sure you can handle the test I give it to you, because all the time I'm gonna say is, hey, use the definition alternative derivative. In order for you to get a point, it's not gonna be using power rule or chain rule. And besides power rule, chain rule, we're gonna deal with much harder stuff. And we also give you an example that power rule and chain rule doesn't do any good here. And a situation like that is very, very interesting. But yeah, if you did it right, you should get, what'd you say, 34? It's possibly. Right. Here I just want to make sure you know how to factor. A lot of you guys know how to have factoring issues still. And if you do it right, you should get 34. Did you guys get 34? No. Okay. Oops, my bad. Sean, you got 34? Jackie? So you should end up to get 34 if you do it right. If you want me to go over, you let me know. Yes, Jackie? Okay. So what other situation I cannot use whatever rule he was talking about? Of course that we can use power rule and stuff like that. But that's not the key. The key is to be able to do other things. So I just say f of x is equal to x minus 3. And this one is, you don't have the chain rule, product rule, or quotient rule. It's not very useful at the situation. F of x equal to absolute value x minus 3. There's no way for you to do that. But we can graph it though. So there's two ways to do this. One is to understand the graphing perspective of calculus. And this is the understanding. So 1, 2, 3. So at this 3 here is going to create something called sharp turn. So the sharp turn is going to be like this. And the other side is going to be this. Okay, so the red side is going to be x minus 3. And the left side is going to be negative x minus 3. Hopefully you already know how this works. Then let's just say if I want to find derivative of the blue line. There's no way for me to find a blue line because we don't know how to take out a derivative. So let's just figure out derivative approaching 3 from the left. So what I'm going to do is I'm going to take a derivative of this. X approach 3 from the left of this function. Now, obviously, we're going to do absolute value x minus 3 over x minus 3. If you do the definition of derivative, it's going to be minus 0, and then there's x minus 3. So then it's going to be limit x approach to 3 from the left. It's going to be negative x minus 3 over x minus 3. So x minus 3 cancel out, that's going to be negative 1. So if I take derivative from the left-hand side, using definition of alternative derivative, because if I plug in 3, it's going to give me 0. So it's going to be x minus 3 absolute value. But absolute value, you're going to use a negative side, so it's going to be negative 1. If I want to take a derivative of the positive side, it's going to be the x minus 3 over x minus 3. So if that cancels out, that's going to give me 1. So I'm going to write down x minus 3 over x minus 3. And then that's equal to the limit x approach 3 from the positive side. It's going to be x minus 3 over x minus 3 because I just changed the absolute value, which is 1. So guess what? And we're going to introduce you something. When the function is not differentiable, this is the case. So function is not differentiable. Remember, this is very, very important. Okay, function not differentiable at a few situations. At a place is not continuous. For example, the vertical asymptote. The whole, right? Or jump discontinuity, or jump. The second situation and third situation is kind of important. Is the one that they always test on. It's the second and third. The second and third is called sharp turn. And that's not a mathematical meaning, but just sharp turn. Which is slope on the left does not equal slope on the right. The third is called vertical tangent. Okay, we're gonna see what happened here in this case. This case, if you see it carefully, we don't even need to do calculation. We can figure out slope of the left side. What is slope of left side? Negative 1, good. And what is slope of the red line? 1. Slope is equal to 1. So, but the problem, left does not equal to right. So at that particular point, it's not differentiable. So you can actually see it. So what is f prime of, let's say, negative 4? That's equal to 1, equal to negative 1, sorry. If f prime of, let's say, 10, that's going to be 1. Does that make sense? Because on left side, the slope is going to be 1. On right side, it's going to be 1. On left side, it's going to be negative 1. And what happens if I'm looking for at 3? Well, at 3, the slope is not equal to each other. One is at 1, one is -1. It does not equal to, therefore does not exist. So the derivative does not exist. Now what we're gonna do is actually we wanna show you something else. We're gonna show you the situation is I'm gonna draw a big triangle. And this big triangle is very important. It's very common tested on AP exam. It's so common that usually it takes around 5% of the test. So understand this. So the first part is gonna be the bottom. The bottom is basically limit exists. So limit exists means limit x approach to the a from the left of f of x equal to limit x approach to a from the right of f of x. Means you could have something like this. Visually, it's going to look like this. So limit doesn't exist. To the open circle or closed circle, it doesn't matter. Long as they are connected in some connected way, limit exists, right? And then we're going to talk about second one. The second one has 3 things. It's on your test. F of A has defined. It has to be a closed circle. So a closed circle there. Second, limit x approach to a of f of x must exist, which is that means it has somewhat a connected point. So in this situation, it's like this. And the third situation is those 2 dots must equal to each other. 2 dots in a circle must equal to each other. So we limit x approach to a from both sides is equal to f of a. So that is to be left side equal to right side. So this is called continuous. We already learned this too. We just put in the picture. The last one is differentiable. So what do I mean by differentiable? Differentiable. So that means the function can take a derivative at this time. So basically it's really easy. It's actually, I'm going to write outside, which is limit x approach to a from the left of f prime of x equal to limit x approach to a from the right of f prime of x. So left side slope had to equal to right side slope. If they don't equal to each other, guess what? Limit does not exist. So a perfect example is this. Think about roller coaster, right? If one side of slope just says 1, and the connection there is a slope like 2, so it looks like this. Do you think this is a good roller coaster? You have a drastic change of slope from 1 to 2. I think this is not going to be functional. They're going to crack this thing really easily, or going to jump out the rail. So you don't want to happen. It has to be completely smooth. It has to be completely smooth. So the roller coaster cannot have something like this. That's just not going to work. Or something like, even like something like this. It doesn't work, right? So it's not differentiable at that point, at the turning point, the sharp turn points. Okay. The sharp turn is like absolute value of x. And the vertical tangent is x to the 2/3 power. It's called a cusp. So those are the few things where not differentiable. When it's not continuous, for example, vertical asymptote, hold, and jump. But the other two is the one that I always tested, is a sharp turn. They're not going to ask you. And actually, if you say sharp turn, they don't accept it. Basically is they want to see this. They want to see this thing right here. Limit x approach to a from the left of f prime x does not equal to limit x approach to a from the right f prime of x. So that's called differentiable. Are we okay here? So you have to know all those things laid down because this is probably the most important notes of it. Talk about 5% of the test. If you don't understand it, it's going to be a problem. Now let's talk about here. So therefore, limit x approach 3 of absolute value x minus 3 over x minus 3 is equal to does not exist. If you reach from one side, it's going to be -1, which one side is going to be +1. But you can also tell by looking at the slope. The slope here is -1, the slope here is +1, but here is the function isn't defined. So function is not differentiable. Okay, last one is this. Last one is the function like this. F of x is equal to x to the 1/3. X to the 1/3 looks like this. Most of you guys don't remember what does x to the 1/3 look like. I'm going to review it again. F of x equal to square root of x is look like this, like an eyebrow. Like an eyebrow. Do you guys remember like eyebrow? It looks like this, right? This one is cube root of x. It looks like eyebrow, but it's both sides, but the other side is going to be inverted. So it's going to be like something like this. It's going to be something like this. If I draw a slope going from here, if I draw a slope here, it's fine. But slope right here is going to be a vertical tangent. Vertical tangent derivative is not differentiable. I'm going to show you why not differentiable. This one, I cannot use the definition of derivative. I can use power rule, but that's not telling me anything. So I'm going to use a definition of derivative. X approaches 0. I want to know what happened at 0. Of x to the 1/3 minus 0 over x minus 0. So it'll be limit x approaches c of 1 over x to the 2/3.
So if c is not defined, then it is by default just 0?
What?
So if c is not defined, then by default it's 0?
Not necessarily 0. I hear it's actually not differentiable.
Okay.
I hear it's not differentiable. I'm going to show you why not differentiable though. If it's 1 over a small number, like number really close to 0, a good example would be 0.1, right? That's 1 over 0.1, so it's about 10. Does that make sense? 1 over 0.01 is going to be what? 100. 1 over 0.01, 01 is going to be 1,000. However, if I approach 0 of x to the 2/3, it's going to be less than 0.001. It's going to be so small, the top part is going to become overweight, so it become positive infinity. Now think about a slope that has positive infinity. It's a vertical line. So vertical line is also known as does not exist. Does that make sense? So vertical tangent is does not exist. In this case here, if I draw a slope at this point, guess what? It's a vertical line. It does not exist. Does that make sense? Jackie, does that make sense? Think about 10, slope of 10, right? And I'll show you on decimal, slope of 10. And I'll show you what the x 2/3 power is. X to the 2/3 is going to be like this. It looked like a cusp, right? And at that point, you think about it here, you don't want a roller coaster to be look like this. That's like the worst way to die on a roller coaster. There's nowhere to go. You can't even make a jump, right? But at this point here, do you see this tension here? it's almost vertical because going like this and gonna become vertical tangent. It's a vertical tangent, it does not exist. Okay?
Have a good day.
Bye, thank you.